In this module, we turn theory into a real, deployable eIDAS solution. You'll see how HSM's PKI and deployment choices fit together, and how to translate high-level regulatory language into an architecture you can confidently defend to auditors. eIDAS and FIPS 140 solve different problems, but in practice they meet in the same systems. eIDAS is about legal trust and identity. It defines when an electronic signature or seal is legally equivalent to a handwritten one across the EU, and what qualified means in law. FIPS 140, in contrast, is purely technical. It specifies how cryptographic hardware must resist tampering, protect keys, and run approved algorithms. As a qualified trust service provider, you can't choose just one. Qualified signatures must use certified secure signature creation devices, typically HSMs that are both FIPS validated and evaluated under eIDAS schemes. So your architecture has to satisfy legal assurance on one side and hard security guarantees on the other at the same time. You can think of a secure digital trust system as having a brain and a vault. The PKI is the brain. It decides who is trusted, how certificates are issued, and when they should be revoked. It runs the rules for identity, certificate life cycles, and status checks like CRLs and OCSP. That's where trust structure and policies live. The HSM is the vault. It holds the private keys, makes sure they're only used in allowed ways, and shields them from physical and logical attacks. All critical signing or decryption happens inside that protected boundary. Together, PKI and HSM form the core engine. PKI makes the trust decisions, and the HSM guarantees that the underlying cryptography can't be quietly bypassed or stolen. Choosing an HSM deployment model means trading off four things: control, performance, regulatory friction, and agility. On-premise clusters give you maximum control, and usually the simplest regulatory story, but they're slower to scale and can be costly to operate. Cloud HSM improves agility and often latency, but you surrender some governance and may face questions around jurisdiction and shared responsibility. HSM-as-a-Service pushes agility further, at the expense of direct control and sometimes compliance comfort. For eIDAS-style use cases, a hybrid model is often ideal. Keep your crown jewel CA and qualified signature keys on-prem for maximum assurance, and burst high-volume, non-qualified workloads into cloud or HSM-as-a-Service for elasticity and cost efficiency. Now let's look at how that architecture is structured in practice. As four logical zones a signature request travels through. It starts in the public zone, where users and their devices live. They don't need to know anything about HSMs or PKI, they just access a portal or app. Next comes the identity zone, which proves who they are. This is where your identity provider authenticates the user and issues tokens or assertions. Then the request reaches the application zone. Business logic runs here. Is this user allowed to sign this document with this profile right now? Finally, the cryptographic zone is where actual trust is anchored. Root and issuing CAs, HSMs, and monitoring systems hold and use the private keys, enforce policies, and generate audit trails. Everything above can evolve over time, but this bottom zone must remain extremely controlled and stable. A complete eIDAS-style signature flow connects those zones, identity, applications, and the HSM, into one chain. First, the user proves who they are to an identity provider, often with strong or multi-factor authentication. The IP then issues a signed assertion to the signing application that says, this user is authenticated at this assurance level. The signing application links that identity to a specific certificate and key and sends a signing request to the HSM using a crypto API. Inside the HSM, the private key operation is performed and an audit-logged signature is returned. Finally, the signature is validated against the issuer's certificates or OCSP, and the user receives a verifiable, legally trusted result. When you turn a compliant design into a real eIDAS service, operational assurance rests on four pillars. First, observability. You need centralized logging, immutable audit trails, and SIM correlation, so you can prove, after the fact, exactly which key did what and when. If it's not logged, it didn't happen. Second, scalability. Plan for transaction volume, benchmark HSM throughput for your chosen algorithms, and understand your saturation points before you go live. Third, load distribution. Run stateless signing services behind Layer 7 load balancers, manage session stickiness carefully, and avoid hidden state that ties you to a single node or HSM. Finally, resilience. Design for failure with disaster recovery, business continuity, tested RTO and RPO, and regular drills, so you know you can restore keys, services, and trust under pressure. An active resilience blueprint means both data centers are live, taking traffic, and each has its own HSM cluster. The crucial element is how keys are replicated. Instead of exporting keys in plain text, the HSMs synchronize partitions over a secure replication channel, using wrapped keys that never leave the hardware boundary in the clear. That's the zero exposure promise. From a reliability perspective, you get high availability and disaster recovery in one. If a site fails, the other already has up-to-date keys and can keep issuing or verifying signatures. From a compliance perspective, both sites must meet the same eIDAS and FIPS 140 expectations, with documented RTO and RPO, so auditors see the DR site as a true peer, not a weaker backup. Everything we've covered comes together as a synthesis of mandate and architecture. eIDAS gives you the legal trust mandate, how identities, signatures, and evidence must behave to be accepted in court. FIPS gives you the cryptographic security mandate, which algorithms, modules, and controls are acceptable. Your SLAs add the operational mandate, how fast, how resilient, and how available the service must be. Your architecture is the implementation of all three at once: HSM-backed keys, PKI and identity services, active-active replication, and controlled processes around them. And none of this is static. Regulations, guidance, and algorithms evolve. So the real end state is a living system you continuously monitor, audit, and adapt, without breaking trust or availability.